Hello, this is Mr. Stansbury. I'm going to take you through one of the problems here on the 16D Part 2 assignment. We're going to take a look here at number 2. Lucy bought a large packet of Chewy Chews lollies. She counted the number of lollies of each color it contained. Her results are shown in the table. The manufacturer of Chewy Chews claims that they make equal quantities of each color. Lucy wants to test the manufacturer's claim with a goodness of fit test using a 10% level of significance. Okay, so first thing, part A, write down the hypotheses that Lucy should test. Okay, so we're going to have the proportions of all of the lollies, right? So I would say P1 is going to be the proportion of red lollies. So P1 equal the red lollies. I'm just going to even just go with the color, just red lollies. And then let's see, let's do P2 is going to be yellow. P3 is going to be green. And P4 is going to be blue. Okay. So if we are going through and setting up, we use this so that we can set up our hypotheses, right? So we're going to, with that, we will say HO, our null hypothesis, will be that the probability of each of these should be, since there's 4 of them, probability of each of these should be a quarter, right? So probability of 1 should equal 1/4. Probability of 2 should equal a quarter. Probability of 3 should be a quarter. Sorry, I'm trying to put commas around all these to make it a little easier to understand. Probability of the 4th one should be a quarter. And then, of course, our alternate hypothesis would be at least one of these. Let's do one of, let's do P1 will not equal a quarter. P2 will not equal a quarter. P3 will not equal a quarter. Or P4 will not equal a quarter. Okay, so at least one of these should be true. Okay, so that's part A. Part B, calculate chi-squared calculated. So that's where we're going to want to make ourselves our nice little table. And then, again, probably the easiest way, probably the fastest way is going to be to plug it into the calculator. Okay, so let's set up our table. Okay, so we set up our table here. And since there are 4 of these, we want to take 65 and divide it by 4. So 65 divided by 4 gives us 16.25 is our expected for each one of these. So we'll write those down for each of these so that we can enter that into our calculator. Again, I'd like to show at least one of the how to do one of these by hand, but especially with the 0.25, it's going to be a little bit more painful. So I'd rather just do this on the graphing calculator. So what we're going to do is we're going to do the observed minus the expected squared. So 12 minus 16.25 is going to be negative 4.25 squared. Take that and divide it by 16.25 and we'll get our number. So just again to do one by hand, we will do parentheses negative 4.25 squared. That gives us 18. Divide that by 16.25 and we get 1.1115, right? And again, we can do that for all of these here, or we can simply go into stats, edit, and then just put these 2 columns of data in there. So this is from the last assignment, so we'll clear those out. And we will now enter in this data. Okay, so we've got all the data entered into our calculator. So then we simply, now that we have that, go over to edit. We're going to go over to tests, and we're going to do the chi-squared goodness of fit, which is down here a little bit. Here it is, chi-squared goodness of fit. All of our observed data is in list 1. Expected data is in list 2. Degrees of freedom. If you remember, what we do for that is we get rid of one row and one column of data, and what we have left, 1, 2, 3 pieces of data. So our degrees of freedom would then be 3. Okay, and we go through and we calculate and hope that we get the right answer here. Okay, so we get that our chi-squared value is 2.02. Oops. Let's go back to blue. So we get a total of 2.02. This is our chi-squared calculated, right? Okay, so our next part here is to find the critical value, the chi-squared crit for the test. So that's where we have to use our table. So we are at a 10% level of significance. So that means we're going to look in this column here. And then we have our degrees of freedom that we already calculated earlier on our calculator, because remember we got rid of this row, this column, and we had 3 spots left. So that's going to mean that we take this row here, and where they intersect is 6.25. So for part C, we get that chi-squared crit, or critical value, is going to be equal to 6.25. Okay, so now using our new chi-squared critical value and our chi-squared calculated value here and here, we're going to use that for part, that's a 5, use that for part D. Does Lucy have enough evidence to reject the manufacturer's claim? So for part D, if you'll remember, our rejection inequality here is going to be if, so reject HO if, reject HO if, and I'm going to rewrite it so that it's similar to what we've been doing for all of our T tests. And let's do this, reject HO if chi-squared critical is less than or equal to the chi-squared calculated. The textbook has this written opposite with the inequality flipped around. It obviously means the same thing, but just to maybe keep things more consistent for us, that might make it a little easier. So if we set this up, our chi-squared critical value here is 6.25. Is that less than or equal to our chi-squared calculated, which is 2.02? This is false. So we don't reject HO, so that means accept HO. So we're going to accept HO, which means way back here that our probabilities are pretty close, or close enough to, at least at the 10% level of significance, to being equal to a quarter. We'll go back and use the wording that the question has. Does Lucy have enough evidence to reject the manufacturer's claim? Lucy does not have enough evidence to reject the manufacturer's claim. Okay, and then last part is part E. I'm going to move this up to give us a little bit more space. E here says verify your answer examining the p-value. Okay, so that is our rule on that one, is reject HO if, and remember that's if our p-value is less than our level of significance. So in this case, our level of significance is 0.1, and our p-value should still be on our calculator, and there it is, 0.569. 0.569. Is 0.569 less than 0.1? That is false. So again, we don't reject HO, so we accept HO, right? Which means that on both cases here using both tests that there's not enough evidence to reject the manufacturer's claim here. Okay? So we again conclude that HO should not be rejected at a 10% significance level. Okay? Okay, that's all we have for the 16D Part 2 problems. If you have any further questions, please feel free to ask in class. Thanks.